This is Unit 3.1. It's the beginning of our quadratic equations unit. This is on foiling and factoring, which are two of the tools you're going to have in order to do the problems for the rest of the chapter. So the objective here is students will expand binomials and factor quadratic trinomials. So before we get started, there's three vocab words on this page you need to know. One is binomials, and that's an expression that has two terms. Remember, terms are things that are separated by a plus or minus sign. So a binomial has two terms, a trinomial has three terms, and quadratic means that somewhere in there a variable is squared. Because when you square something, a square has four sides, so it's quadratic. So the trick to remembering how to multiply two binomials together is the word FOIL, where F is first, O is outside, I is inside, and L is last. FOIL. So here's the kind of problem we'll be doing. We have two binomials. One binomial is x plus 3. The other one is x plus 4. So what we're going to make sure we're going to do is we're going to multiply every term in the first binomial by every term in the second binomial. Now the easy way to remember how to do that is by using FOIL. So first, we want the first term in each binomial. So in this case, that's x and x. And x times x is x squared, so we write that first. Then the next term in our new expression, we multiply the outside numbers together. So in this case, x and 4 are on the outside of the problem instead of the middle. So x times 4 is 4x, so we put plus 4x. Now remember, each of these multiplications is going to be a new term in our new expression. Then I is inside, that's 3 and x, so that's 3x. And then last is 3 times 4, because those are the last numbers in each binomial. 3 times 4 is 12. So I'm not quite finished here yet because I have to combine like terms in my new expression. Now one of the things you have to remember is that x squared does not combine with 4x. Not only, in order to have like terms, not only do you have to have the same variable, but that variable has to be raised to the same power. So x squared does not combine with 4x. But 4x does combine with 3x. I add those together. 4x and 3x gives me 7x. And the 12 doesn't go with anything either. So the final expression, the final trinomial that I get as an answer when I FOIL out two expressions is x squared plus 7x plus 12. One of the interesting cases that comes up when you FOIL is the product of a sum and a difference. So here I have a plus b and a minus b. So it's the same two numbers or variables, whatever a and b happen to be, only the difference is one is a plus sign and one is a minus sign. So let's see what happens when we do that. When we FOIL, we get a times a for the first term, so that's a squared. Then we have a times negative b, and that's a minus ab. Then we have b times a, they're both positive, so it's ab. And they have plus b and minus b, and that's, since it's a plus and a minus, it's a negative number, and it's negative b squared. Now if you look at this, you can see minus ab plus ab, well, since they're the same, they have opposite signs, they're going to cancel out. So what I'm left with is a squared plus b squared. So that's a shortcut we can use. Like this example, we have 4y plus 3 and 4y minus 3. Well, we know that's going to be a squared minus b squared. So 4y squared is 16y, 4y squared is 16y squared, and 3 squared is 9, so it's 16y squared minus 9, and I'm finished. Now this problem is one that comes up often. A lot of times I'll see this one, a plus b to the second power, and people will write a squared plus b squared, and that is not correct. One of the things that's very important to remember for the rest of the class is that you cannot distribute an exponent. You have to rewrite the problem as two binomials and then FOIL them together. So a plus b squared, remember squared means multiply it by itself. So if I take the quantity a plus b squared, then that's the quantity a plus b times the quantity a plus b. And hopefully you can see now that what you have to do is FOIL this expression. So a times a is a squared. A times b when we do the outsides is ab. B times a when we do the insides is ab. And b times b is b squared. So you'll see we have two ab's in the middle here. So what this ends up being when we combine like terms is a squared plus 2ab plus b squared. So every time you have a plus b squared, you know to expand it as a squared plus 2ab plus b squared. Example, x plus 3 squared. Well, in this case, a squared is x squared, b squared is 9, and ab is 3x. But we have a squared, which is x squared, plus 2ab, which is 6x, plus b squared, which is 9. And you can see how that works. Remember, ab is 3x. So that's the square of a binomial. That's all we're going to talk about foiling today. And actually, none of your homework has foiling. Foiling is something that comes up as a skill, and you'll have to use it in other problems. And since you have to use it so much, I'm not going to test you directly on foiling. It's just going to be part of other problems. What we're going to use foiling for now is to learn how to factor. And that's to go backwards. So if you see in this problem, the one I have on the right, x plus 3 squared is the original, the thing that would come out of the book, and the answer is x squared plus 6x plus 9. When you factor, you go the other way. The question in the book is going to say x squared plus 6x plus 9, and your answer needs to say x plus 3 squared. So in order to be able to work backwards and unfoil things, first I'm going to see the patterns that emerge when I foil things that don't have numbers to go with them. So I'm going to see how things combine so I can capture the pattern. So in this case, I have x plus heart times x plus spade. And I multiply the first, well, I was multiply everything out. X times x is x squared. X times spade, which is the outside terms, is spade x. Heart times x, the inside terms, is heart x. And the last terms are heart spade. And if you see here, I have two like terms that I can combine, and that's spade x and heart x. So if I knew what numbers spade and heart were, I would just add them together and put it next to x. So there's a mathematical way to write that, and that's like this. So I have x squared plus heart plus spade plus heart spade. So if I have a trinomial that I need to factor, x squared, you see that's x squared. 8x, you can see that that replaces heart plus spade, and 7 replaces heart times spade. So what I'm really looking for is two numbers. One where if I add them, the sum is 8, and one where if I multiply them, the product is 7. Now, if you think about it, there's only two numbers, there's only one set of numbers that works for it, and that's 1 and 7. So if I go back to the original, I know it has to look like that original problem, the x plus something times x plus something. So in this case, I know those two things have to be 1 and 7. So the answer looks like this. Here's another example just to get to show you how I would solve this problem and how you should solve this problem too. When we see x squared plus 8x plus 12 and I'm trying to factor it, the first thing I write, before I even think about it, is I write this. I know that's what my answer is going to look like because that's what it looks like when you factor an expression. All I have to figure out is what goes in those blanks after the plus signs. So the first thing I want to think about is what two numbers can multiply and give me 12. Now when I think about it, the first two numbers that come into my head are 4 times 3. So I would be tempted to put 4 and 3 in those boxes, but then I remember that not only do those numbers have to multiply to give me 12, but they have to add to give me that 8 in the middle. And 4 plus 3 is 7, not 8. So the numbers can't be 4 and 3. So I think of other numbers that can multiply and give me 12. The next ones I think of is 6 and 2. So 6 times 2 does give me 12. And the question is, does 6 plus 2 give me 8 in the middle? And it does. 6 plus 2 is 8. So that means the two numbers that go here are 2 and 6. It doesn't matter which one you put first and which one you put second, so long as you have 2 and 6. And that's all you have to do is factor this expression. Another easy thing to factor are those the sum and difference formulas. So you see where if we have a plus b times a minus b, we figured out that was a squared minus b squared. Well, that's pretty easy if I have something like this. Something where I have a perfect square, something I can take the square root of, minus something else I can take the square root of. So the square root of 16y squared is 4y, and the square root of 9 is 3. And so since I know I have an a squared minus b squared, that means the original pre-foil before I foil it had to be 4y plus 3 and 4y minus 3. So here's your homework. If you look in the book, the numbering makes more sense. You start with number 1 and you just do everything in the left-hand column until you get to number 19. Good luck on your homework, and I'll see you next class.